Hi everyone. Welcome to the Getting Started with Java screencast for Advanced Java Programming at Portland State University. In this screencast, we're going to learn about some of the fundamental tools for working with the Java programming platform and walk through building a very simple Java application. When we're done, you'll be able to identify several of the key tools for developing Java applications, and you'll see an example and be able to edit and build a functioning Java project. The first tool that you'll need for advanced Java programming is the Java Development Kit. This is a suite of tools that includes the Java language compiler, the tool that parses Java source code and turns it into bytecode, the Java virtual machine, which provides the runtime environment for working with bytecode, the standard Java libraries, which we'll learn a lot more about later in the course, and tools like JavaDoc for generating readable documentation for your code. The Java Development Kit can be downloaded from this URL on Oracle's website. Be sure to download the JDK, the Java Development Kit, version 7 or later. This page explains that several of the different Java packages, and again, you want the JDK. And after you download it, this page will also tell you additional installation instructions, any configuration that's necessary, and provide other links for getting started with Java. Now, I've already got the JDK downloaded on my machine, and so the way I can tell that Java is configured properly is to look at the value of my Java home environment variable. Looks reasonable, JDK 1.7. And I can run Java to make sure that I've got, Java 7 or Java 1.7 installed. The second tool that we'll be using a lot in advanced Java programming is Apache Maven. Now, Apache Maven is a build tool that provides conventions and configurations for building a Java project. There are lots of pieces and parts to a Java project. You've got your Java source code, which could be application code, and then you can also have test code that tests your Java application. And then really what Maven provides is a life cycle that will compile your code, will run your tests, assemble your artifacts. These are things like jar files or web applications that get deployed into a web container. We'll be learning about those later in the course. Maven has a plugin architecture that supports a number of different kind of reports about your code, about your application. We'll build documentation, websites for projects, for software projects, and things like that. It's very powerful and really kind of complex. Probably the biggest advantage of Apache Maven is that it manages your third-party libraries that you use for your project. Now, almost every Java project of any size, even the ones that you'll see in this course, include source code that's written by the author, but then also leverage other libraries. For instance, libraries for a unit test framework, or libraries for working with web applications, or XML parsers, or really anything else. And Maven provides tools for downloading third-party libraries from central repositories, and really alleviates a lot of the pain and tedium of going out and finding third-party code and working with it. You can download Maven from this URL right here. For this course, we'll want Maven 3.0 or later. Maven itself is written in Java, and so all you need is the Maven classes, the Maven jar files as a zip file or a gzip tar file. Basically, download the Maven archive, unzip it in a place on your hard drive, and configure a couple of environment variables, and you're ready to go. All this is explained here on this page. To make sure that you've got Maven configured correctly in your environment, check the value of the Maven home or the M2 home variable, and then run maven -- version to make sure that it executes correctly and that you're using version 3.0 or above. I have a series of slides that goes into much more detail about Apache Maven. They can be accessed here from our website, and they'll be featured in another screencast. The last tool that we'll use in advanced Java programming is an integrated development environment. Now, what an IDE is a powerful user interface for editing Java source code, for building Java projects, really working with your Java application. There are a number of IDEs out there, and also if you are more comfortable or maybe are an expert at a more simple text editor, something like VI, Emacs, TextMate, you can use that for this course. There's no problem there, but I've found that having a good IDE will help you learn the language better, learn the libraries better, and help you become a more proficient Java developer faster. My preferred IDE, the one that I use and I've had a lot of success with, is a tool called IntelliJ IDEA from JetBrains. There is a free community edition, which ought to be good enough for this class, but there's also an ultimate edition, and we have an academic license for that will last throughout the term. And I'll be giving that license in class. But in the meantime, you can go to this URL and download IntelliJ. Again, you want the Ultimate Edition, which comes with a free 30-day trial, and then once class starts, you can get the license key for the year-long license version. It's easy to install and run, and there's plenty of documentation on the JetBrains website. Now, while IntelliJ is the IDE that I prefer, you don't have to use it. If you are already experienced with another IDE such as Eclipse or NetBeans, feel free to use it. They'll work perfectly fine for this class, and they'll work really well with Maven. Now that we've seen some of the tools that you use to work with the Java programming platform, let's walk through a simple Java project. First off, we're going to use Maven to create a skeleton project, a template, if you will, for us to start with. And then we will edit our code in IntelliJ. And in this exercise, we want to get our unit tests to run. The template project comes with a couple of unit tests, and we want to get our code in a place that the unit tests pass. We'll be working with the student project from Advanced Java Programming. This is sort of a project 0. It's optional, and it's a good example of the kinds of things that you'll be doing at the beginning of the course. And we can see all sorts of details about the assignment here at this URL. So for this sample project, you'll create a student class. The subclass is human that was discussed as part of the object-oriented programming lecture. Now, human is a class that I wrote, and you, the student, will write your own student class. The subclass is mine. This is one of the primary goals of this project, is to work with someone else's class. We'll also have an opportunity to learn about inheritance and virtual methods, and then read program arguments from the command line. In the first couple of projects in Advanced Java Programming, we'll be reading user input from the command line arguments. So not from standard input, but from command line arguments. This is admittedly simple, and very few people write command line tools very much these days. But you got to walk before you can run, and so we'll focus first on writing good Java programs, and then towards the end of the course we'll be using more advanced tools like REST and Google Web Toolkit for rich internet applications for interacting with the user. But first off, we're going to be working with this simple human class. Now here in the assignment I have the source code for it. If you'd like, you can copy the source code into a student.java file, but I also created something called a Maven archetype that we can use for generating generating a Maven project for working with this student class. A Maven archetype is essentially a template for a project, and there is a Maven plugin called Archetype that is used with these things. To get started with the archetype, probably the easiest thing is to simply cut and paste this big old command line that I've hit here, the assignment, into your command window. So I'll do that now. Before I hit enter, I just want to quickly walk through what all of this stuff means. MVN, of course, is the Maven command line script name. And archetype :generate means run the generate goal of the archetype plugin. So basically we're saying, hey, generate an archetype. Now we need to tell Maven where it finds that template to build a project from. And I host that template, that project up on my website. And the name of that archetype is student-archetype, and its group ID is edu pdx cs410j. So I'm going to hit return. We'll see what happens. So Maven has gone off, and it looks like there's an error that's been encountered. I'm seeing something that looks like a Java stack trace, and sure enough, it says no archetype defined. Well, let's scroll up and see what's wrong. See here, warning, error reading archetype catalog, blah, 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 blah. Well, that doesn't look like the right kind of tilde now, does it? Okay, this is actually something that students run into a lot when cutting and pasting from the PDF. There's some problem with the PDF that the tilde that it uses is some fancy tilde, not the plain old tilde that we would expect on the command line. So, oops. I'll Control-C out of this, and we'll start over again with a URL with the correct tilde. Delete that tilde and replace it. There you go. There's a big old school tilde. Let's try that again. Okay, that's making more progress. Remember how I said that one of the best features of Apache Maven is that it handles third-party libraries. Well, it does this by downloading all sorts of jars and POMs from repositories out there on the internet. And here's an example of it doing that. It's downloading this archetype jar file, this student archetype jar file from my website, and also the associated POM file. We'll learn more about POM files later. Probably when you run this yourself, it will download all sorts of Maven plugins and things like that. It'll look like it's downloading the entire internet, and it pretty much is. It might take a little while, but eventually it'll finish up. Of course, the advantage of this is that it downloads it to your desktop, to the machine that you're running Maven on. It only needs to download it once. So even though the first time it might download, it might take a little while, subsequent times it'll just use those local copies, and it'll be much faster. Okay, the Maven archetype plugin is asking me for the group ID of the project that I'm created. The group IDs for this class will be edu.pdx.cs410j your username, which is in my case Whitlock. The artifact ID, this is the name of the project itself. That'll be student. And the version, it doesn't really matter. 1.0 snapshot is fine, so I'll just hit return. And the package, this is going to be the package for your Java source code. edu pdx cs410j Whitlock, that's fine with me. Okay, ask me to confirm it. Looks good. And off it goes. And so what it did is it took the archetype, it took that template, and created a well, a customized shell project for you. So now if we change to the student directory, that's where the generated code lives. You'll see that there are a couple of files. There's something called a pom.xml, and that's a configuration file for Maven. It's a big old ugly XML file that tells Maven what to build. We'll dig into more details later. I'll spare you the details. We'll save that for the Maven lecture instead. And then in your source directory, you have your main application, which is student.java, and then in your test directory, you have a test. So I encourage you to write unit tests for your code, and this sample project, this project 0, gives you a place to start. We'll look at that shortly. Oops. So the first thing, well, let's build a project and see what happens. And the way to build a project is to say Maven package. Now Maven package will do a couple of things. It will download any dependencies. It will compile the source code. It will compile the test code. It will run the unit tests. And if all of that stuff is successful, it will build a jar file that contains your application. So let's see what happens. Looks like it's downloading some code, some stuff that it needs, and it failed. It bombed. What does it say? Let's see here. Failed to execute goal, blah, blah, blah. Compiler plugin, compilation failure, error. It looks like it's complaining about something in student.java, constructor human, cannot be applied to given types. Okay, well, let's see what's going on here. We could open up the student.java in VI, in Emacs, in your favorite text editor, but I prefer to use IntelliJ. Luckily from Maven, there's a really easy way to create an IntelliJ project from your Maven project by saying idea:idea. And that will create some IntelliJ files, these student.iml, student.ipr, student.iws. I don't know exactly what those mean. I do know that the IPR is the file that I want to open in IntelliJ. So I suppose I could go and find the application and open it that way. On the Mac, there's this nice open command that will launch IntelliJ for you. And I'll do that now. Okay, well, IntelliJ has opened the student project, and well, no files are open, and it's telling me some things. I can open project view with Command 1 or by clicking over here on the project tab over here. And what file view allows me to do is look through the files here, my project. Here's the student class. You can navigate to a class and open it that way, but you can also navigate it to it in the project view and find it that way. You can also use commands in the navigate menu. So for instance, to open a class, the way I like to do it is I like to use this navigate to a class or command N. And what this does is prompts you for the name of a class. So in this case, I want to open up student. And I'll say I found 2 classes with the word student in them. I don't want student test, I want regular student. And I'll hit return and open that up. And so now I'm looking at my, my student class. Just scroll up a bit, look at the source code. Here it is, the package the class is in is that package that I entered when I created my Maven project. And created the rest of the stuff from the template. It's got some imports, only a couple. It's importing this human class and the standard Java util array list. And you can expand and collapse these with these dudes. So IntelliJ is all about helping you get your code nice and clean and running. And just like the compiler output from the Maven command line, IntelliJ is telling me that things are bad, and the way it tells me is that it underlines things in red. So here I am looking at the constructor for my student class, and it says there is no default constructor available in human. Well, let's see here. Human is the superclass of student, and I think it's telling me that it needs to invoke one of the constructors of human, but I don't know what those are. Luckily, I can navigate to the human class and look at its source code. So I'm going to click on human here, and I can say navigate to declaration or Command B on my Mac, or also I can hold down the Command key and click on the human class. So this takes me to the source code for human. This is good. Okay, human extends something called mammal, whatever. And okay, look, human has one constructor, and it takes a string, which is the name of the human. Okay, that's good. That's good to know. This is one more thing I want to point out about this class. This is a class that I wrote, and the source code for this class isn't part of the project. If I were to change the source code and recompile the project, it wouldn't change. The source code is my source code. It lives someplace else. Instead, when I built the Maven project, everything got linked together by Maven. And the way you can tell this is if you look up in the title bar here for the window, it says human.java, and then it comes from some jar in the Maven repository, often your local repository, not the project itself. Anyway, it's one of the things I wanted to point out, that even though you're working with my code and you can see my source code, you can't change it. Okay, so back at student, I've got this guy complaining that there's no default constructor, so I need to call one of the constructors. And let's see here, I call a constructor by saying super, and what was the parameter again? I could go back and look, but there's also, if I say command P, it'll tell me what the names are, what parameters are to that method. So it's string name. So I'll just send the name of the student to the superclass's constructor. Note that when I typed the word name, IntelliJ prompted me for various things. Do you mean the parameter name? Do you mean the method get name? In this case, I want the parameter name, so I'll hit return or tab to get that. Okay, it seems to be happy now. That little red line went away. But I see another red line down here, missing return statement. Okay, yes, obviously I have a method that says that it returns a string, but there's no return here. Now I can look at this comment and see all students say this class is too much work. Okay, so I think that informs what the implementation should be. Return, oh, thank you, suggestions. This class is too much work. Okay, good. Now I don't see it on the screen, but I know there's another error in this source code, because over here on the right, next to the scroll bar, there's a little red region right here, another missing return statement. If I click on it, it'll scroll to that. Okay, so returns the string that describes the student. Well, at the moment, I don't know what that string ought to be, and so I don't want to try to guess, because really the first thing I want to do is I want to get my code compiling, then I want to get my unit tests running, so I'm going to put this aside for the time being. I don't know what to do here. I'll come back to it later. Now, I could have it return null, I could have it return the empty string, but I want to be a little bit more drastic than that. I want to throw an exception, right? Because this code isn't complete. I need to compile, but it's not done yet. So I wanted to throw an exception, and thank you. Throw new. Unsupported operation exception is the one that I'm going to use. The standard exception in the Java programming, in the standard Java APIs. We'll learn more about it in a later screencast. So I'll take that one. And oh, it's prompting me for parameters. I'll put in a little message that says not implemented yet. And that means if anyone does try to call this, they'll get this exception and they'll know that it's not implemented, and that person probably will be me. Anyway, okay, so I don't see any more red. Looking over here to the left, though, there is a warning in yellow, and those are there 3 warnings. Parameter class is never used, gender is never used, GPA is never used. So now I'm going to go back to my my command window, my terminal window here, and I'm going to run that Maven package command again. Okay, compiling. Looks like I made a little further. I saw some tests go by, and now it ends with an error. Failed to execute the Surefire plugin. I just happen to know that Surefire is the plugin that runs tests. There are test failures. Okay, well, let's scroll up and see. It ran some tests in student test. It got 2 errors. Okay, it looks like something was unhappy then. I want to go look at the student test source code here. I'll go back to IntelliJ, and I will use Command N. Oh, it remembered that I typed in student, and so now I'll go down to student test. Okay, and I'm right here. Now let's see here. Big old comment up here. JUnit test, they extend this invoke main test case, which allows us to invoke the main method of student. They also use this hamcrest thing to make readable assertion statements. Okay, that's cool. Let's look at this. Okay, wow. I've got a unit test method with a very long name. Invoking main with no arguments has exit code of 1. It's very long, but it's really quite descriptive. Okay, so when I invoke main, I expect, invoke main with no arguments, I expect that there is an exit code of 1. Let's see what this method does. It calls something called invoke main. If I hold down command and hover over that, it says that, oh, it's a protected method from invoke main test case. Okay, well that must invoke the main method. Invoke main test case is actually some code that I wrote. It's here in one of my packages. Okay, and so it invokes main, and I send it student.class. We'll learn about exactly what .class means in the reflection lecture in a couple more weeks. Until then, though, we'll just say that this is how you invoke main on the student class. There's a main method on the student class. We'll go look at it in a second. So I invoke main, I get something called a main method result, and it looks like when I want to assert something. So in a unit test, you set up some state, you run some the code under test, and then you assert or verify that the expected output occurred. And so in this case, when the exit code of calling that main method ought to be 1, and it's not. I could go back to Maven and run it again, but you can run your unit tests inside IntelliJ by using the run menu, and I say run. It's giving me a choice. Do I want to run just that one method, or do I want to run all of student tests? Now I'll run both of them. There's only 2 of them. Not a big deal. I hit run. It goes and builds my project, chugs away, and okay, it props up this whole run window down here with some details. So I'm going to click over here on the invoking main with no arguments, prints missing arguments to, I'm sorry, let's do this one first. Invoking main with no arguments has exit code of 1. So it's saying, okay, I expected 1 but was null, and that was here on this assertion statement. Okay, so get exit code. Now exit code is the thing that is the value that is passed to system.exit. So I think what this code is saying, what the test is saying, is that when main is invoked with no arguments, should have exit code of 1. Let's go back to the student class and see what our main method does. Oh, our main method does nothing. So to make that test pass, when main is invoked, oops, with no arguments, system.exit with the value of 1. Okay, well, I changed that. I'm going to rerun my my unit tests. Hey, look, one of them turned green. Invoking main with no arguments that has xcode of 1 is green now. Awesome. Let's double click on this guy. It tells me, let's see here, the assertion error failed as a string containing missing command line arguments is what it expected, but it got an empty string. And the name of this test is invoking main with no arguments prints missing arguments to standard error. Oh, prints the string missing command line arguments to standard error. Okay, so then here again, we evoke main with no arguments. Yes, with no arguments. And we assert that what was written to standard error contains the string missing command line arguments. Okay, again, see if we can make it happy. Before we exit the system, we will print to standard error, print line, missing command line arguments. We'll rerun our unit tests. 2 passing. The bar is green. Hey, this is good. Okay. So then everything's passing. I want to go try it again from the command line. See if Maven is as happy as IntelliJ is. I'm just going to up arrow here to do Maven package again. Okay. It's building, it's compiling. Things have changed. By the way, if I hadn't changed my source code, it wouldn't recompile it. Hey, build success. Okay. So I'm just going to scroll up to see that, yes, indeed, no failures on my unit tests. Very nice. Okay, so I've got my project built, and I'm going to go back to the assignment. Okay, I've got my project all built, and now it's saying that I can run that main method by using an executable jar. Right. So we'll see more details of this later, but we make an executable jar that basically has all the classes that it needs on the class path. If I copy this java-jar, so instead of having to put the name of the main class on the Java command line, I can just point the Java virtual machine at that jar, and I can run it, and it's telling me missing command line arguments. So it's running that main method of student. And hey, just for the sake of testing, what happens when I pass an argument to there? It prints nothing. Cool, right? Because I mean, all it does right now is when there's 0 command line arguments. When there's 1 command line argument, it doesn't do anything else, which probably isn't the right final behavior. But I'm feeling pretty good about where I'm at right now. I've got the code running. I've seen how to write some unit tests, and I think I want to stop for right now. That and also the screencast is probably like way too long already. So that's it for right now. So I'm going to put this aside for a little bit, but we're going to pick it up in another screencast because there's still a lot more to do.